This is video 2 to help with the trig test review. I'm going to cover problem 7, 8, and 9 on the second page. For number 7, you are asked to solve for x and y on these triangles. And when you look at them, hopefully you notice that these are special right triangles. We have a 45, 45, 90 triangle, a 30, 60, 90 here and here. So this would be our 30. If you want, fill in any missing angles to help you out. What's going to be important is for you to remember your relationships for your triangles. Remember, for a 45, 45, 90, your sides are x, x, your hypotenuse is x squared roots of 2. And for a 30, 60, 90, your short leg is x, your hypotenuse is 2x, and your long leg is x squared roots of 3. So if we take a look at this triangle here, we need to recognize that we are given no sides for this one here, but we're asked to solve for y. For this 45, 45, 90, we know no sides, but we've got our angles. So that means we're going to have to start with this triangle here where we know the hypotenuse is 20. So what we should understand is that for a 30, 60, 90 triangle, the hypotenuse is twice the short leg. So if this is twice the short leg and we solve that, that tells us that x has a value of 10, or this side here, which is going to be the x value because this 30, 60, 90 triangle and this 45, 90 triangle share a common side. So we know that our x value is 10. Now we have to somehow get over here to solve for y, but we don't have any side measures. What we need to recognize is that for this 45, 45, 90 and this 30, 60, 90, they share common sides. And since for a 45, 45, 90, the legs are congruent, if this leg has a measure of 10, then this leg is also 10. And that's going to help us to solve for our legs. Now, in order to solve for our hypotenuse, we really need to know what the short leg is. So let's find our short leg. That's going to be our x value. And then remember, our hypotenuse is twice that x value. And once we know that, then we can solve for y. So what we do know is that opposite the 60-degree angle measure, so this technically is your long leg, even though visually when we look at it, it may not look longer. This leg is opposite the 60-degree angle, so this is our long leg, which is x squared roots of 3. Right here, x squared roots of 3 on your long leg. So that means x squared roots of 3 is equal to 10. Now we just need to go about solving for x and then rationalizing, and that's going to give us 10 squared roots of 3 over the square root of 3 times the square root of 3 is the square root of 9, which equals 3. So this is the value of our short leg, 10 square roots of 3 over 3. Remember, your hypotenuse, which is this y value, is twice whatever the value of your short leg is. Yeah, that was 10. So that was, your short leg is 10 squared roots of 3 over 3. So we need to take this 2 and here substitute our x value, 10 squared roots of 3 over 3, and multiply. And that will give us 20 squared roots of 3 over 3. 20 square roots of 3 over 3. All right. Moving on to the graph of this cosine function for number 8. We want to take a look at what we've got here on our graph. We've got our intervals on our x-axis marked in intervals of pi over 4. We look up here and we recognize that for a cosine function, we've got to know that our period is 2 pi. So just like we did in our activity, we should remember for the cosine function, which kind of looks like that V figure, right? Then it looks kind of like this. Then that means we want to start with our max and our min values. Well, for the cosine function, it's at 1, and then at 2 pi, 1. Halfway between that at pi would be at -1. Halfway between that would be our zeros. So that's what the normal cosine curve would look like. So what we can do here is recognize from left to right, we're going to transform this function. First by changing our amplitude to +2, So you can either erase it. That's what I'm going to do because I have a pencil. So that means my max is at 2 and at 2 pi 2, where my min would now be at negative 2. So I can gauge that that's kind of what it looks like now, just by changing our amplitude. So we know that 2 is our amplitude. Remember, amplitude is always the absolute value of your A. So the absolute value of 2 is 2. Next comes our frequency rather. Our frequency is the number in front of x. Well, since there's an understood 1 there, our frequency is 1. That means it actually is not going to change the period. Moving on, because the next thing we would do is use our frequency value to determine our period to see if we need to shrink or stretch it. We need to fill in for our period that our period is 2 pi over b. And since that's going to be 2 pi over understood 1, our period is just going to be 2 pi. So that's good. We don't have to compress it or stretch it or anything. Our phase shift refers to our horizontal shift. Remembering that it's always the opposite. Like if you see a plus sign, that means you're going to go in the negative direction. So that tells us we're going to go left pi over 2. So please make sure you put in here not just pi over 2, but left pi over 2. Or you can put negative pi over 2. That also indicates that you're going left. Either of these would be acceptable, either left pi over 2 or negative pi over 2. So now that's what I'm going to do to my graph, is take all of my points and shift them left pi over 2. So remember, these intervals are in pi over 4, so that means we're going to have to move every point 2 spaces to the left. And then the last part is our vertical shift. Our vertical shift is the up and down shift, which is this, our D value. So vertical shift is your D. And remember, your phase shift is technically your phase shift is C over B. So your vertical shift, we're going to go up 1. So again, please put up or down depending on whether it shifts up or down. So that means all these points are going to shift up 1 unit. So I'm going to take this point shifted up, this point shifted up, that point shifted up. Recognize that because our our amplitude was 2, that means our midline, well, by the way, our midline was at 0. Now it's shifted up 1 as well. So whatever the vertical shift is where your midline is. So that means I'm going to, if it helps, erase all these other points. Oh, yep. If you want to graph this in colors with pens, that's fine. I'm just going to use pencil so you don't have so much up here it looks confusing. So again, we took our original point, shifted it left 2 units, which was pi over 2, and then up 1. Halfway between these two, so if I go up here, halfway between these is where kind of like my zeros would be, except they're not directly on the axis, but on the midline. And now I have my 5 points that allow me to graph 1 cycle of cosine. So please understand, you only have to graph 1 cycle. 1 cycle is enough for me to see that you understand your transformations. Now remember, your range is always your lowest value to your highest value. Our lowest value here is at -1. Our highest value is at 3. So my range is going to be from -1 to 3 inclusive. Alright, lastly, we're going to graph this sine function. So our sine function, remember, we have 3 points on our x-axis at 0, and at pi, and at 2 pi. Halfway between each of these, we have our max at 1 and then min at -1. So that's what our graph looks like normally. We're going to start here and recognize that we have a negative in front, which means our graph will reflect. So that means my max now becomes a min, my min now becomes a max. And I'm just going to erase the other one. If you want to leave it dotted, that's fine. I just don't want y'all to get confused, so I'm going to erase. All right, the next thing we have to recognize is that, oh, and by the way, our amplitude is the absolute value of -1, which would be 1. Our frequency is the number in front of x, so that's going to be 3. But remember that affects our period. So that means our period is 2 pi over 3. Remember, your period is 2 pi over b, and since b is right here in front of x, we're going to have a period of 2 pi over 3. We also need to remember that if our b value is here in parentheses, we're going to need to factor that out. So I'm just going to come over here and say, well, this means that my function is negative sine with 3 on the outside. The way I figure out what goes on the inside is I factor out a 3 by dividing each term by 3. So 3x divided by 3 is x, and then I'm going to have 3/4 divided by 3. I'm not even going to make this hard, and I recommend you do this too. 3/4 divided by 3, and then hit math, enter, enter, and we get 1/4. So this tells us we're going to have minus 1/4. So that means we're now ready to graph our function. We have already reflected it. We need to now adjust for our period. Remember, like we did in the activity where we modeled them with human beings, that we keep our start point where it's supposed to be, but we need to put a point at 2 pi over 3. So recognize that 2 pi over 3 is 2/3 the distance from 0 to pi. We definitely did one just like this during our activity the other day. So that means if I divide this up, 1/3 and 2/3 is going to be about there. Maybe I could leave a little more room. Let's see. Alright, so about 1/3 and 2/3 the distance. So that means I want my new end point to be right there. So I'm going to erase the rest. And this is where I'm going to end. Well, if this is where I end, I have to remember that for the sine function, halfway between is my other 0. Halfway between there is my max. And halfway between here is my min. Alright. So I have my 5 points. That's what it would look like. And I'm ready to do some shifting. So the first thing I need to do is shift all of my points to the right pi over 4. So I'm going to put up here right pi over 4. So I'm going to take all these points and shift them over pi over 4. So here, and I'm going to use a pen at this point, over pi over 4, over pi over 4, over pi over 4, over pi over 4, over pi over 4. So I'm going to shift in pi over 4, and then I'm going to shift them all. So this is what I look like now. There's my graph. I'm going to use a different color, and I'm going to take all of my points and shift them down 2 units now. So my vertical shift would be down 2. So down 2, down 2, down 2, down 2, down 2. And since I'm done with everything, I'm going to use a solid curve. Alright, so that looks pretty good. There's my graph of that function. In terms of my range, my lowest y value is -3. My largest y value is +1. So remember, we always take our range from our lowest y to the highest y. And that concludes the graph. If you get confused with these, remember I've got 2 videos posted from last Wednesday and Thursday to help you out with that. And that really what we're looking at. And if you need to use your note card, which I gave you, to help you with studying, you can. But that's the function we're dealing with, okay? Good luck with your studies, and look next for the video to help you with the last page. Good luck.